Okay, oops. Try and fix things up. Okay, so let's talk a little bit more about the left coset. I have this. Okay. Yeah, let's talk about the left cosets. But actually, in addition to that, all the left cosets, like they have the same size. Okay. So I guess we can write this as maybe like proposition. Okay. If H is finite, then the number of elements in the left coset of G is always equal to the number of elements in the left coset of some other coset, G prime. And the proof is you just construct a bijection between the two sets. Let's call it F. By F of GH is just equal to take G, the element of the left coset, and take it to what I guess G prime G inverse times GH. And now you get an element of G prime H. Okay. And this is a function that is one-to-one and onto. Okay. So it's a bijection between these two sets, and so these two sets have the same number of elements. Okay. So all the left cosets have the same size. We can break, so G, the left coset's partition G, that means we can break up G into a bunch of pieces, all of which have the same size. So as a, which is pretty important for us. Here we go. Okay. Let H be a subgroup of G. Let G be a finite group and let's define this notation. G colon H, this is the number of left cosets of G, of H and G. Okay, then Lagrange's theorem says that the number of elements of G is equal to the number of elements of H times the number of left cosets of H. For a finite group. Okay. That is Lagrange's theorem. Okay, and we're not gonna, you don't have to prove it now, but if you think about it, to draw kind of like a picture like this, here's G, and the cosets of H are all these like pizza slices. Okay, so here's H, here's BH, here's CH, DH. Oh, I don't want to use E. Okay. Okay. Okay, so divide G up, like cut it up into slices. Each slice has the same number of elements, and there's 8 slices. So now the number of elements of G is just the number of elements in each slice times the number of slices. Okay, sorry about that. Okay. So that is Lagrange's theorem. And that is one of the important things about left cosets. But the other, we can sometimes we, like we did with the integers mod n. Okay. So sometimes we can multiply left cosets like we can take AH times BH, and we can try to define, we can try and make this the product to just be A times B, the coset of AB. And this seems fine, but it actually turns out it doesn't always work. The reason why it might not work is because each left coset has a bunch of different representatives. So it might be that choosing a different representative gives you a different left coset. Okay, so in order for it to make sense, what needs to happen? In order for this law to be well defined, we need to take AH times B prime H, and so if we have that, like say BH equals B prime H, we need that when this happens, we need a B prime H. So we need for a B prime H to be equal to a BH. And not only that, we also need, like, what if I change A with A prime? So if B and B prime are the same left coset and A prime are the same left coset, and this happens if H in G. So what does this mean, normal? Well, you have a definition. So let H be a subgroup of G. We say H is normal in G. And write this symbol. Let me write this symbol bigger. It's supposed to be like a triangle. with a less than, with the equal sign below it. So we write this if GH, I'll write it like GH G inverse equals H for all G. Okay. Okay. So that's what we call a normal subgroup. If we have a normal subgroup, we can make the left cosets of H to be a group as well. Okay. So theorem, if H is a normal sub, then G mod H, which is just defined to be the set of all left cosets of H. This is a group under the law, the multiplication, you know, take G times H times G prime H. That's just GG prime H. Okay. Okay. So G mod H is called the quotient, like the quotient of G by H, things like that. As our only example so far, we have take H to be the multiples of N and G to be the integers, then G mod H. And here the group law is addition. Okay. So the left cosets are 0 plus the multiples of N, 1 plus the multiples of N, all the way up to N minus 1 plus the multiples of N. And the group law of G defined by this, you just get, to add two left cosets, we just add their representatives. Okay. And the equivalence relation, like congruence mod H, is just congruence mod N. You know, K is in L plus NZ if and only if N divides L minus K. Okay. Okay, I guess there's just one more thing I still want to tell you about today. well, at least one more thing. Okay, and that is so let's take G to be a group, and let's take an element of G, and let's define the order of G. This is will denoted. It's denoted by I think it's best to do like O of G, not to be confused with little o notation. Okay, define the order of G. The least positive integer D such that G to the D is the identity. Okay. And just a quick fact, the order of G generated by G. And from this, you get that, I guess we could put this as fact one. The second fact is that if n is the number of elements of G, and G is in G, then G to the n is the identity. Okay, so far, let me give you a picture of where we are. We have some knowledge of groups, some knowledge of subgroups. We have some knowledge of like generating sets. We have left cosets. We have some knowledge of quotient groups. And then what's missing for us before we continue is homomorphisms. And also more and more examples of groups. Oh, I see there's a chat. Sorry if I've missed it for a while. The page before, well, I'm just going to turn back to that page. Here, I see it now. Okay. Oh, I guess. No, you're right. That is just, I don't think this will be shown in the recording. So the question is like, on this page, why do I have, we need for AB prime H equals ABH? Why isn't it? The reason I wrote that is because it's a mistake. So it should really be that. Okay. The reason is that it was, yeah, not correct. Okay. Now if I correct it, then it says what it's asking us is, you know, we have the same left coset but different representatives, same left coset but different representatives, different left cosets. That would be bad. The condition that guarantees that good things happen is this condition that H is normal in G. Okay, thank you for that correction. I think that's a good place to stop. So I'm going to stop here. I'm going to try to mark your. Okay, I will reply to it ASAP. Sorry about that. Okay. Okay, yes, I guess that's it. We'll meet again on Monday. Yeah.